Did you know that the sun is so large, over 1 million Earths could fit inside it? Yes, you heard that right. The sun, the fiery ball of gas that lights up our days and gives life to our planet, is so enormous that it could comfortably house more than 1 million of our blue-green planet. Now, to give you an idea of the sun's mass, it's about 333,000 times the mass of Earth. That's approximately 99.86% of the total mass of our entire solar system. As for its volume, well, it's about 1,412,000 cubic kilometers. To put that into perspective, you could fit about 1.3 million Earth-sized objects inside the sun. But don't let these numbers fool you into thinking the sun is just a big inert gas ball. It's a dynamic, active, and ever-changing star that's vital to our existence. That's a lot to wrap your mind around, isn't it? Let's dive deeper into the sun's structure. The sun, like any star, has a specific structure. It's not just a big ball of fire. Let's dive into the sun's structure to understand the magic that powers our solar system. The sun is composed of several layers, each with its own unique role in creating and distributing energy. At the very heart of the sun is the core. This is where the magic happens. The core is where the sun's energy is generated through nuclear fusion. Here, hydrogen atoms are compressed under incredible pressure and heat, transforming them into helium and releasing a vast amount of energy in the process. Surrounding the core is the radiative zone. In this region, energy created in the core travels outward in the form of light. It's a slow journey, though. The energy bounces around in this zone for thousands of years before it finally makes its way to the next layer, the convective zone. The convective zone is where the sun's energy gets a free ride. Here, hot plasma rises towards the surface, cools down, and then sinks back down to be reheated. This process of convection is what brings the sun's energy closer to the surface. As we reach the surface of the sun, we encounter the photosphere. This is the layer of the sun we can actually see. It's where the light finally escapes into space, and it gives the sun its distinctive yellow glow. Above the photosphere, we have the chromosphere. This is a thin layer that emits a reddish glow, but it's usually hard to see unless during a solar eclipse. Finally, there's the corona, the sun's outermost layer. This layer is only visible during a total solar eclipse, where it appears as a halo around the sun. The corona is incredibly hot, even hotter than the surface of the sun, and it extends millions of kilometers into space. So, the sun is more than just a bright light in the sky. It's a complex, layered entity. The sun is a powerhouse, literally. Its energy is what makes life possible on Earth. Now let's dive deeper into the core of the matter, pun intended, and explore the workings of this massive energy factory. At the heart of our sun, a process called nuclear fusion takes place. This is where the magic happens, where hydrogen atoms under immense pressure and temperature combine to form helium. In this high-energy dance, some of the mass of the hydrogen atoms is converted into energy, following the famous equation by Einstein, E equals mc squared. That's energy equals mass times the speed of light squared. This energy, released in the form of light and heat, is what fuels the sun and gives it its glow. Now you might be wondering how this energy makes its way to us, over 93 million miles away. The journey of a photon, a particle of light, from the sun's core to its surface is not a straight shot. It involves countless interactions with matter, being absorbed and re-emitted, bouncing around like a pinball in an arcade game. This zigzag journey can take a staggering 100,000 to 1 million years. Once the photon reaches the sun's surface, it's flung into space in all directions. Those photons that head towards Earth take about 8 minutes and 20 seconds to cross the vast emptiness of space and reach us. That's right, the sunlight you're basking in right now is actually over 8 minutes old. This sunlight is the driving force behind all life on Earth. It powers photosynthesis, the process by which plants convert sunlight into food. It drives our weather systems, creates our climates, and even powers solar panels, providing us with clean, renewable energy. Without the sun's energy, our planet would be a cold, lifeless rock. So the next time you feel the sun's warmth on your skin, take a moment to appreciate the incredible journey that energy has made, from the heart of the sun to you. The sun's influence extends far beyond just providing light and warmth. Indeed, This colossal ball of glowing gases does so much more, and its impact on our Earth is profound. Let's start with weather and climate. The sun plays a crucial role here. It's the primary driver of Earth's weather system. As the sun's rays heat the Earth's surface, they create temperature variations. These variations result in wind, as air moves from high-pressure areas to low-pressure areas. These winds, coupled with the Earth's rotation and the properties of water, give rise to complex weather patterns. The sun's energy also influences the Earth's climate. Its heat causes the evaporation of water, forming clouds that bring about rain and snow. Through a process called the water cycle, the sun helps distribute heat around the globe, creating different climate zones. From the icy poles to the scorching deserts, from the temperate forests to the tropical rainforests, each climate type owes its existence to the sun. But the sun's influence doesn't stop at weather and climate. It also plays an indispensable role in sustaining life on Earth. It's the sunlight that powers photosynthesis, the process by which plants, algae, and some bacteria convert carbon dioxide and water into oxygen and glucose. This process not only provides oxygen for us to breathe, but also forms the foundation of most food chains. Through photosynthesis, plants produce fruits, seeds, and leaves, which are food sources for herbivores. These herbivores then become food for carnivores. This way, the energy from the sun is transferred from one organism to another, supporting a diverse array of life forms. Without the sun, there would be no photosynthesis, no food, no oxygen, and consequently, no life as we know it. So, whether it's driving our weather, shaping our climate, or powering the intricate web of life, the sun's influence is pervasive and vital. It's a constant, life-giving force that we often take for granted. But as we've seen, its role extends far beyond just being the bright object in our sky. The sun truly is the heart of our solar system. Our sun is about 4.6 billion years old, and it's only middle-aged. Imagine a star's life as an epic journey, a cosmic voyage that spans billions of years. It all starts in a nebula, a vast cloud of gas and dust. Within these nebula, pockets of gas begin to condense under their own gravitational pull. As they shrink, they heat up, and when the core temperature reaches an astounding 10 million degrees, nuclear fusion ignites. This is a star's birth, the dawn of its life. Our sun, just like other stars, spent a significant portion of its life in a phase known as the main sequence. This phase makes up about 90% of a star's life, and it's the period during which a star shines the brightest. During this phase, the sun is in a state of hydrostatic equilibrium, where the inward force of gravity is balanced by the outward pressure from nuclear fusion in the core. This delicate balance is what keeps a star stable, but nothing lasts forever, not even stars. As a star exhausts its supply of hydrogen, it starts to contract under its own gravity. This increases the core's temperature and pressure, causing the star to expand and cool down. This stage is known as the red giant phase. Our sun will eventually become a red giant, engulfing the inner planets, including our own. Yet, the sun's story doesn't end there. After the red giant phase, it will shed its outer layers, leaving behind a dense core known as a white dwarf. This white dwarf will cool down and fade over billions of years, becoming a black dwarf, a silent testament to the star it once was. In about 5 billion years, our sun will undergo some dramatic changes. But don't worry, we have plenty of time to enjoy the sunshine until then. Today, we've journeyed through the sun, exploring its structure, energy production, impact on Earth, and life cycle. We've delved into its captivating layers, from the scorching core to the cooler outer surface, each having a unique role in making the sun what it is. We've uncovered the secrets of nuclear fusion, the process responsible for the sun's vast energy, which lights up our days and powers life on Earth. Speaking of Earth, we've seen how the sun's energy not only sustains life, but also influences our planet's climate and weather. And finally, we've traced the sun's life cycle, from its fiery birth to its eventual transition into a red giant and white dwarf. A constant reminder of the cosmic drama unfolding over billions of years. So, the next time you feel the sun's warmth or see its light, remember the incredible celestial body that makes it all possible. Until next time, keep looking up.